Hello, ladies and gentlemen. Today we're going to take a look at some solving equations and how these radicals come into play. So this should be a review in terms of the solving of what you've already done, and then we'll see how these radicals become a part of that in dealing with radical answers. We're also going to take a look at how this ties into where we're going with geometry here. So you'll see why we've been spending so much time dealing with these radicals and simplifying them. So prepare yourselves today for some square root answers and dealing with those square roots, but the algebra steps to solving an equation should be familiar to you. So here's our first example. I need you to get into your notes. We have 5x squared plus 4 equals 96. Now, if I was going to solve for x, I would want to isolate this x right here. In fact, the x is squared, but we'll deal with that later. But we want to use inverse operations to isolate that x. So the first thing I would do is add 4 to both sides. So on this side, I'd have 5x squared equals 96 plus 4 would be 100. Then I would divide by 5 to continue to isolate that x. I'd have x squared equals 20. So when I look at that, we're asking ourselves, what number squared equals 20? Well, that's not going to be a perfect square number that I know right off the bat. So to undo the squaring, we would use the inverse operation of square root. So we would take the square root of both sides. So on this side, I would have x left because a square root and a squared are inverse operations. And over here, I have the square root of 20. Now, I can't just give the decimal answer. I need to keep this in simplified radical form. So we need to break apart that square root of 20 using a perfect square. 4 times 5 is 20. So I really have the square root of 4 times the square root of 5, which would be 2 square roots of 5. So I have 2 square roots of 5 as my answer. Now there's one little catch. You should remember that anytime you have an x squared, that power up here tells me how many answers my problem should have. So if we think about this in terms of a simpler problem, what if I said, what number squared equals 49? Well, you might say that's 7. But I would say it's also 7 and negative 7. Both of those numbers, when I square them, both give me a value of positive 49. So we have a positive answer and a negative answer. We need to keep that in mind here as well. I really have a positive or a negative 2 square roots of 5 for both answers. All right, let's look at another example here. Here I have 5x squared plus 33 equals 3. So we're going to go through the same steps. We're going to subtract the 33 here. And I'd end up with 5x squared equals negative 30. Dividing by 5, x squared equals negative 6. And then again, I would go to take the square root. And now what number squared equals negative 6? Well, no number squared would ever give me a negative value. So we can't find a solution here at this point. You won't really need to find solutions when you have a negative underneath a square root until you get into Algebra 2 level math where we deal with imaginary numbers. But for right now, we're just going to write that this actually has no solution, that we can't find the square root of a negative number. All right, let's look at a third example. Negative 2x squared plus 6 equals negative 9. So I would go ahead and add the 6 again. And then I have negative 2x squared equals negative 3. Then I would divide by the negative 2. That's the coefficient there for the x squared. Negative 3 divided by negative 2 is actually positive 3/2. No decimals, guys. Leave those as fractions. And then we would go ahead and once again take the square root. And so I'd get my x by itself. Now over here I'd have the square root of 3 and the square root of 2 happening. Now this seems okay, but we can't leave a square root in the bottom of a fraction, remember. So I'll multiply the top and bottom of the fraction by the same square root of 2, and I get square root of 6 over square root of 4, which is the same thing as square root of 6 over 2. So my answer is square root of 6 over 2. That's the simplified version of the square root of 3/2. So again, I place plus or minus in front, accounting for my two solutions, both the positive square root of 6 over 2 and the negative value square root of 6 over 2. All right, let's look at a fourth one. So this one already has a fraction in it. Let's go ahead and isolate that x, but the first thing I would do is actually subtract this 6 here, and I'd have 3x squared divided by 14 equals, on the other side, I'd have 6. So now to undo the dividing by 14 that's happening here, I would multiply both sides by 14. So I'd take 6 times 14 and I'd get 84. So I'd have 3x squared equals 84 because a multiply by 14 and a divide by 14 are inverse operations. Then I would go ahead and divide by 3 to get that x squared alone. And I'd have 84 divided by 3 is 28. And then last but not least, I'm back to the square root part. So I would square root both sides, and I'd have x equals the square root of 48, or 28, sorry, which I would split apart into 4 and 7. The square root of 4 is 2. The square root of 7 I'm going to leave alone, and then plus or minus in front. So all of this solving, why do we need to work on solving for x and dealing with these square roots and simplifying our answers? Because we're going to use this in geometry quite a bit. In fact, one place that you use solving using square roots is the Pythagorean theorem. So if you don't have this already memorized, you might want to write this part down. The Pythagorean theorem says that in a right triangle, we have a squared plus b squared equals c squared. That means that the two legs squared and then added together will equal the hypotenuse squared. So a squared, b squared equals c squared, okay? So knowing that a and b are the legs and the c is always the hypotenuse, we can find a missing side of a triangle, a right triangle, if we're given the other two lengths. So for example, this would be one that you would want to write your last example into your notes. If you have 6 and 10 as the legs of the right triangle and you're trying to find the hypotenuse, we would use the Pythagorean theorem to do this. A squared plus b squared equals c squared. So we would say one of the legs is 6, the other leg is 10, and the hypotenuse is x. So 6 squared is 36, 10 squared is 100, equals x squared. 136 equals x squared then. And then we would go ahead and take the square root of both sides. Now notice again, we have to simplify the square root of 36, or 136. So the square root of 136, that is not a perfect square, but 136 does divide by the perfect square of 4. So we'd have 4 times 34, and that is in fact the biggest. So we would have 2 square roots of 34. Now, do we need to place the plus or minus in front of our solution in this case? And the answer to that is no, because I'm trying to find a missing side of a triangle now that's different than if I'm trying to find or solve some solution to an algebra problem. Missing sides of triangles shouldn't be negative values. We shouldn't have negative sides of triangles. So all I need is the positive value of 2 square roots of 34. Okay, so we're going to continue to solve using square roots, and we'll practice when we get to class. Thank you for taking good notes.